Hello and welcome to the MLOps Minute. In this video, we're going to continue making your code testable using dependency injection. In the previous episode, we created a job class which takes as a parameter to its constructor an instance of a class implementing irandom. This enabled us to take control of the randint method and run a test. One problem remains: this job class does read and write disk accesses. And that's a real problem because there's a strong coupling between the job class and how the data is written and read. Data, if tomorrow we want to change and save in a database or web service, we're going to have to impact this job class, so it's a strong coupling. What's more, we have no control over unit tests to perform unit tests. In fact, our test is still not a unit test. Why? Because if we want to play this test in a continuous integration environment, for example, GitHub Action, a remote server, the remote server may not be allowed to write data to the hard disk. It probably won't have access to a database if you're using a database, or to a web service if you're using a web service. As a result, it won't work automatically. And this kind of testing, where physical accesses are made, isn't called unit testing, it's called integration testing. And that's something really important to understand. As soon as you access a physical resource over which you have no control, we call it an integration and not a unit test. And here I want to decouple my job class from how I write and save data. That's why I'm going to use dependency injection. Here we go. I'm going to create an ipanda. Copilot helps me a lot. It offers me 3 methods, but I only want 2. A read JSON, where I'll read a JSON from a path, and to JSON, where what I want is to save a JSON from a data frame. We'll add a parameter. We'll type. Now this interface I'll be able to use it because what I'll want to do is inject an instance of a class that responds to this interface in my job class. Perfect. Here I've created a field. Now it's telling me it's red. We'll create a default implementation right away. Default panda, which implements my methods and creates the real disk access. This default implementation that we'll configure by default. What happens is that as a result, I can use my little property for use it in my doJob method. Data frame merge method, and that's it. I need to put the path. First, save path, data frame merge, perfect. Now it's perfect. I've decoupled my job class from how the data is saved. Now let's take a look at my tests. In my previous test, I have a problem. I'm going to load data from this to load data frame from right to left. To check the data frame output, I have a problem. My doJob method doesn't return anything. It doesn't return anything. I wanted to check whether the saved data frame corresponded to what I wanted. To do this, we had to read the disk to compare our data frames. And that's really not clean, because really we're making disk access all over the place. I'm going to comment on the fact that we're going to load onto the disk to check our data frames. And we're going to create a mock. We're going to create a mock that implements the ipanda dynamic mock instance with magic mock. For reading, we'll implement readJSON. What happens is that I've already prepared the left and right data frame. what we're going to do is use a property called side effect, where we can put an array of parameters that will correspond to each call. On the first call, we'll return the data frame on the left, then on the right. Let's check in the job class. First we'll call the left, then the right. It's perfect. My mock here is just what I'm looking for. And we're going to mock the TOJSON method. And then we'll return nothing at all. The good thing is that now I'll be able to do something really cool. I'll be able to check whether my save method is called. And I have the input parameter observed. In other words, I can check the data frame, output of my algorithm. As a result, we should do assert call once with this expected data frame. But in fact, with Panda, equalities are a bit complicated. So what we'll do is just check if the method has been called once. And then here I've prepared a little line. There's a little testing subset in Panda that lets you compare two data frames. So we're going to compare the data frame we're supposed to be waiting for with here, our mock. The good thing is that we can retrieve the number of calls. So here we take the first call, which is the only one, since we've only called any method once, and we'll take the second argument, which corresponds to our data frame, and now it's great, we can make a comparison.
For now, I'm about to run my test, but I forgot to inject my mock when
I instantiate Job, that's it. I'll press Ctrl-Alt-5, and we'll see if my unit test passes. And that's really nice. I'll delete the unused code. The good thing is that my data frames that were hard written on disk, I can delete them. And my test will continue to work. The good thing is that my code, my job class, is no longer responsible for knowing how to save the data. This allows me to test this class. As a result, this class is really clean. You see here, I no longer have any files that have been written that have reappeared. As a result, I really don't have any disk access. As a result, this test is really unitary. It can be run automatically in continuous integration. Thank you very much, and see you soon for more videos.